We're going to look at how to convert from linear unit relationships and unit ratios to ones that are two-dimensional and three-dimensional, so ones involving area and volumes. If we look at the appendix in our textbook with the unit conversions, we will notice that there are a lot of them that involve lengths, and separately there are many that involve areas. If we look at the table that has the area unit conversion factors, we'll notice these involve either acres or hectares. They don't involve things like square feet, square yards, not many involve square meters or square kilometers. So in this video, we will focus on how to take the values given in the length unit conversion factor table and turn those into ones that give unit relationships between areas and volumes. If 10 decimeters is 1 meter, how many square decimeters are in 1 square meter? Well, the unit relationship that we are given is that 10 decimeters is 1 meter. So we can write that unit factor down. 10 decimeters, or 10 dm, is 1 meter, 1 m. But again, these are linear relationships. So if we take this square that is given and consider that to be 1 meter on each side, we also know that it'll be 10 decimeters on each side. Well, if we draw in those 10 decimeters on each side, 10 going in the vertical direction, and then adding in the 10 that go in the horizontal direction, it might become a bit clearer that this 1 square meter given in the picture has 10 decimeters in each direction, or 100 square decimeters in total inside of that square. We're not always going to be able to draw such a picture, so we want to connect what's happening in that image with the unit ratios that we have over on the right side. Knowing that we want to somehow get from a relationship between decimeters and meters to square decimeters and square meters, we can set up the beginning of an equation. We know that we're starting with 10 decimeters over 1 meter as a unit factor, and we know in the end we want to get something that involves square decimeters and square meters. The way to move from this linear unit relationship of 10 decimeters is 1 meter to something involving square decimeters and square meters is to multiply by the same unit factor. So we'll multiply that 10 decimeters over 1 meter by another 10 decimeters over 1 meter. And if we multiply across the top, 10 times 10 will give us 100. Decimeters times decimeters gives us square decimeters. 1 meter times 1 meter, well, 1 times 1 is 1, and that will give us 1 square meter. So by taking a linear unit factor and multiplying by itself, we can move from a one-dimensional unit relationship to a two-dimensional unit relationship. To answer the question, there are 100 square decimeters in 1 square meter. Now to consider a three-dimensional version. If 12 inches is 1 foot, how many cubic inches are in 1 cubic foot? We can begin this in a very similar way. Start with an image of a cube, recognizing that we're going to have this cube being 1 cubic foot, so that means it will be 1 foot wide, 1 foot high, and 1 foot deep. But in each one of those dimensions, there's going to be 12 inches. So another way of looking at this is that this 1 cubic foot will have 12 inches across the bottom. It will be 12 inches high on the side, and it will also, in a moment I'll write this out, it will also be 12 inches deep. Now if we just for a moment consider the front face, it is 12 inches wide and 12 inches high. Well, if we draw in those inches, we can see that we end up with a 12 by 12 grid, or 144 square inches. But when we take that image and add it into the third dimension, we're also going to end up with 12 inches deep. So if we consider this, that there are 12 layers of that front face of 144 square inches, but each one of those square inches is really now a cube. We really on that front face have 144 cubic inches. And that 144 cubic inches only accounts for this first layer of this. That 144 cubic inches there is only one layer of a total of 12 layers, and so we would end up with 144 times 12 layers. So if we write that down, we have 144 cubic inches in that first layer, and there are a total of 12 layers. That gives us in total, if we took into account every one of those 12 layers, this would be 1,728 cubic inches. But again, I don't want to have to draw a picture every time I try to make this type of conversion. Another way to approach this is to use the unit factors that we know. We know that 12 inches is 1 foot, so that can be our original unit factor. We're going to need to multiply that by something in order to eventually end up with some sort of relationship between cubic inches and cubic feet. Similar to what we just did for the area, if we multiply it by another 12 inches compared to 1 foot, that would give us just the front area of that cube that we were talked about originally, the 144 square inches. But to bring it into the third dimension, we would multiply by another 12 inches compared to 1 foot. If we go ahead and multiply across the top, we would have 12 times 12 times 12, which is 1,728. Inches times inches times inches gives us our cubic inches. In the denominator, 1 times 1 times 1 gives us 1. And the feet multiplied by itself 3 times gives us our cubic feet. So we can establish a new relationship that compares cubic feet and cubic inches by using these linear relationships. For this reason, we don't have these volume relationships or area relationships established in the table, simply because they can be derived anytime we need them. To answer the question, how many cubic inches are in 1 cubic foot? 1,728 cubic inches are in 1 cubic foot.